My name is Quinci Henry. I did a project this last week on crime in Austin, Texas, to fulfill my obligations for galvanized data science. I wanted to kind of get a project that encapsulated a lot of the things I learned, and I thought that the crime data set was a good way to do so. So the goal of this is to try to make forecasting better for police jurisdictions in terms of both efficiency and justice. And this is the tech stack I use: Python, NumPy, Matplotlib, sklearn, and Jupyter Notebook. So this is the data we have. We have 159,000 entries. It's not very well populated, but the features are kind of split into three categories. You've got time data, you've got location data, and you've got something that logs the status of something about the crime. So I did some initial EDA on this set, and these are the fields of interest after that EDA, and they're in actually the order that I found them interesting. So the main one I found interesting was longitude, latitude, and XY coordinates, because that was a good indicator of where the other fields would have a bunch of NaN values, basically. Uh, Clearance status, there's three statuses, cleared by arrest or not cleared. These two were descriptions of the event, and then we had the day the event took place. It was called a timestamp, but unfortunately there was no true time of day included in that timestamp. So we have, from left to right, we have features, and on the very far right, we have our target. So the leftmost feature was time data, and this was the way that it's categorized according to which categories had the most severe crime. We see fall and winter were ahead, and all data was in the middle between spring and summer collectively and fall and winter collectively. We have the days of the week here. Sunday and Saturday, known as the weekend, were the times when people did commit the most severe crimes, unfortunately. And it was by quite the margin relative to all data and the lows of the data. This is by day of the week. It goes kind of in a fluctuating pattern, but the biggest one is the first. So now we're going to talk about location. This is how Austin kind of groups the data in location. And I ran k-means on the data, and this was the data set before k-means. But my goal is to kind of see what k-means comes up with in comparison to this. This is by x and y coordinates, by the way. So this is what we came up with. Yeah, so it's clustered pretty nicely, but it is very different from the leftmost, because especially as you get towards the center of downtown, towards the outside, you can kind of see these shapes. They might be consolidated into one cluster or so, but we're really missing this George right here, as they call it. So these were the crimes I labeled severe. I'll give a second to look at those. And this is the distribution of severe to non-severe on the right. The first model we did was a random forest. All data was clustered, NaNs were included, and we see at the top of our Gini distribution, the most important features were those that were NaN. These are our scores, decent. So I kind of wanted to see what would happen if we took out all the NaN values, so I ran another model. And this is when we dropped all the nulls, and we see that, first of all, recall went down a lot. All the scores went down, actually. But all the data that was considered the most important on this model was temporal. So under this conclusion, I concluded that the time data was a little more important under these circumstances and the parameters and things I use, but a more advanced clustering algorithm could allow for locational data that was more predictive than the time data. Future work, I'd like to do some of these things, explore with 10 clusters instead of 9. 10 is the number that Austin used. And I'd like to explore by year as well to see if there was a positive or negative correlation or trend. So I'd like to give thanks to all galvanized students and especially the staff. Are there any questions?